Hi everybody, welcome to my channel. Today's video will be a short physics lesson. More in detail, I will talk about radar and sonar waves. This video's purpose is to help you learn in an easy, fun, but at the same time interesting way about these two types of waves. Before we get started, let's do a quick review of what we have previously learned in physics class. A wave is a disturbance that transfers energy through matter or space with little or no associated mass transport. Waves consist of vibrations of a physical medium or field around relatively fixed locations. They can be categorized as longitudinal or transverse waves. The size of waves vary a lot. There are waves that can be as big as buildings, others can be medium-sized, for example, like a pencil, or even smaller than an atom. Now let's take a look at the different parts a wave has. In the diagram, the dotted horizontal line is called the median line. This line represents the position of the medium when no wave is present. The section of the wave that rises above the undisturbed position is called the crest, and the section that lies below the undisturbed position or median line is called the trough. Moreover, the space between two crests or two troughs is known as the wavelength. The term amplitude may have slightly different meanings depending on the context of the situation. In our case, the amplitude is the length between the crest and the median line. Lastly, the frequency of a wave is how many wave patterns are in a single second. Now we can dive into what we're really here to learn about, radio and sound waves. Did you know these are known as the biggest waves we have access to? Radio waves make up part of the electromagnetic spectrum. These waves are packets of energy with differing wavelengths, similar to visible light waves, X-rays, or gamma rays, except longer. On the other hand, sound is made up of vibrations, or sound waves. These sound waves are formed by objects vibrating. Sound waves travel through air, water, and solid objects as vibrations. A fun fact about these waves is that they are very commonly seen being used in military bases. A radar is an object detection device that uses radio waves to determine the speed, altitude, and direction of objects. Radio waves or microwaves are transmitted from a radar dish. These waves then continue in their paths until they hit an object. A small bit of the wave is returned to the transmitter, making it possible to determine the speed and other characteristics of the object. Radar is a very important tool in the military as it is used to detect aircraft, vehicles, and missiles. The following example, you'll be seeing at the beginning of the video how radio waves work. You can see a tower with radio transmitters or antennas that make it possible for us inside the car to listen to the radio or the music played in different channels. Sonar is a very common technique used in submarines and other underwater vessels. It uses sound propagation to detect objects in the water. This is done by emitting sound pulses and listening for echoes. Sonar is also commonly used in the military to determine the location of other vessels. To demonstrate how sound waves works, I'll be doing a little demonstration. Physics! See, you were able to hear that because those sound wave vibrations hit the wall right back to our ears in the way of an echo, making it possible for us to hear it. The speed of a wave is measured as the distance traveled by the crests or troughs in a given time interval. The relationship is similar to the relationship of speed, distance, and time in classical physics. The general mathematical formula of speed is distance divided by time. For example, if a crest of a wave is covered a distance of 30 meters in 10 seconds, then the speed of the wave is 3 meters per second. But if another crest covered 35 meters in 10 seconds, then its speed is 3.5 meters per second. We can see that fast waves covered long distances in the same time period. Let's take a look back to what we just learned. We started off with the definition of a wave, then we moved on to the different parts of a wave, which led to us learning a little bit about radio and sound waves, which we connected to how these types of waves are used in the military. We saw some examples of these waves, and we finished off with the mathematical part of our video.